All right, welcome back, everyone. So far in this course, we've really spent our time digging into the how of calculus. All the rules, the mechanics. But today we're going to pivot. We're going to focus on the why. We are taking these, let's be honest, sometimes abstract mathematical ideas and putting them to work where it really, really counts, in the world of business, making smarter, more profitable decisions. Think of it as moving from the textbook straight to the balance sheet.
So, let's start with the big question, the one that really defines modern business, whether you're at a tiny startup or a giant like Apple. How do you take what you have, your money, your people, your time, and use it to get the absolute best result possible? See, we're not just looking for a good answer here. We're hunting for the optimal one. How does the company figure out the one single price that will bring in the most money, or the exact dollar amount to spend on ads for the biggest return? These aren't small questions. They have huge financial consequences, and you just can't leave them up to a gut feeling. They demand a much more rigorous, a much more quantitative approach.
Okay, so here's our roadmap for today. We're going to start by getting a really clear definition of what business optimization even means. Then we'll introduce our main tool for the day, calculus. After that, we'll roll up our sleeves and put it all to work in a real-world case study on maximizing sales. And this next part is super important. We'll talk about the common mistakes and pitfalls to avoid. Finally, we'll wrap up by looking at why this skill gives you a massive strategic advantage in your career.
Let's dive right into our first section, business optimization. You see, before we can even think about using our math tools, we have to know exactly what our target is. The word optimize gets thrown around all the time in business meetings. But what are we actually talking about from an analytical point of view? What does it truly mean to find the best?
So, in the world of business math, optimization isn't just about making things a little better. It's the formal process of finding the absolute maximum or minimum value of a function. In plain English, we are using a strict mathematical method to pinpoint the single best possible outcome. It's like you're looking at a mountain range of potential profit. Optimization is about finding the single highest peak. Or, if you're looking at costs, it's about finding the absolute lowest point in the deepest valley. Any other spot on that entire landscape is, by definition, not the best. It's suboptimal.
Okay, so that brings up the obvious question. How in the world do we find these exact peaks and valleys with math? Well, for that, we need a special kind of tool, one that's designed to analyze how things change. And that, right there, is the job of calculus, specifically differential calculus. It's the language we use to describe and analyze rates of change, and that is the absolute key to optimization.
The foundational step, the one that makes everything else possible, is translation. We have to take a messy, real-world business problem and translate it into the clean, precise language of mathematics. And we do that by building a function, a model that describes the relationship between what we care about. For example, we can build a function where our sales numbers depend on how much we spend on ads. That function, sales equals F of advertising spend, becomes our mathematical playground, a place where we can analyze this business dynamic with incredible precision.
Now, if calculus is our language, then the derivative is the most important verb. It's the engine that powers this whole process. Think about our function as a hilly, winding road. The derivative tells you the exact steepness of that road at any single point you choose. In business and economics, this is called marginal analysis. The derivative gives you the marginal return. So for our sales function, the derivative answers the million-dollar question: if I spend just $1 more on advertising right now, what is the exact immediate increase in sales I should expect? That is the incredible power of looking at the instantaneous rate of change.
So this brings us to the actual step-by-step process. First, we model the problem as a function. Second, we find its derivative. And third, and this is the magic step, we set that derivative equal to 0. Now, why 0? What's so special about 0? Well, think about climbing that hill again. As you're walking up, the slope is positive, right? And once you're over the top and walking down, the slope is negative. But what about at the very, very top? At that one single fleeting moment at the summit, the ground is perfectly flat. The slope is 0. The exact same thing is true for the absolute bottom of a valley. So by setting the derivative to 0, we're basically telling the math to find us all the potential flat spots, all the potential peaks and valleys. These are our critical points. All right, we've laid out all the theory. Now it's time to move this out of the classroom and into the boardroom. Let's apply this 4-step process to a business problem that you could very well be handed in your first job out of college. I want you to really picture this. You're the new marketing manager. The company is launching a new product. The CEO walks into your office and says, "We've got a budget for ads, But I don't want to guess, I don't want to range, I want to know the single best dollar amount we can spend to get the absolute highest sales possible. Your job is to come back with an answer that isn't just an opinion, but a number you can defend with data and with math.
Okay, so let's look at the data we've collected from some early test markets. This table tells a really compelling story. Notice that as we bump our ad spend from $20,000 to $40,000 to $60,000, our sales go up. That makes sense. But look closely at what happens next. When we jump from $60,000 to $80,000, our sales actually go down. This is a textbook, real-world example of the law of diminishing returns. After a certain point, maybe the market is saturated, or maybe people are just tired of seeing our ad. More spending actually starts to hurt us. So the data tells us our sweet spot, our peak, is somewhere between $60K and $80K. But somewhere isn't good enough for the CEO. We need to be precise, and for that, we need calculus.
So our next job is to take these separate data points and create a continuous function, a smooth curve that fits the data. We'd use a statistical method like regression analysis to do this. And since the data goes up and then comes back down, a quadratic function, which makes that familiar U shape, or in this case an upside-down U, is a great choice. So let's say our analysis gives us the function s of x equals negative 0.2x squared plus 19x plus 200. S is sales in thousands and x is ad spend in thousands. Now our path is clear. We take the derivative of that function, set it equal to 0, and solve for x. And that x will be the ad spend that takes us right to the top of that sales curve.
And there it is. After we run the numbers, the calculus gives us a single, definitive answer, $47,500. This isn't a ballpark figure. It is the precise, optimal amount to spend on advertising each month. It's the exact point where our marginal return on advertising hits 0. What that means is, at $47,500, the very next dollar we spend would actually start to make our total sales go down. This is the kind of power and precision that a quantitative approach brings to business strategy.
Now, this optimization process, it's an incredibly powerful tool, but with great power comes great responsibility. It is surprisingly easy to make a small error that leads to a really bad recommendation, with serious financial consequences. So this next section is critical. We're going to talk about the most common mistakes students make, and more importantly, how you can avoid them.
Look, simple math errors happen, but the most dangerous mistake, the one you absolutely cannot make, is forgetting to check if the point you found is a maximum or a minimum. Just think about it. Imagine your goal is to maximize profit. You do all the calculus perfectly, but the number you find is actually the point of minimum profit, the point of maximum loss. The result would be catastrophic for the business. You have to verify your results, usually with something called the second derivative test. And one more thing, never ever forget that your mathematical model is a simplified picture of a very complex reality. It doesn't know that your competitor is about to launch a huge sale or that the economy might be heading for a downturn. You always have to use your business judgment right alongside the numbers.
So this brings us to the formal check. You have to know what your critical point represents. When your goal is to maximize something, like profit or revenue, you're looking for the top of a hill, a curve that's concave down, shaped like an upside-down U. Think of it like a cup that's spilling water. On the other hand, when your goal is to minimize something, like costs or waste, you're looking for the bottom of a valley, a curve that is concave up. It's like a cup that's holding water. The first step of setting the derivative to 0 is identical for both, but the final interpretation and the business decisions you make are complete opposite.
All right, for our final section, let's zoom out a bit. Let's move away from the formulas and talk about the bigger strategic picture. I really want to drive this home. What we've talked about today isn't just some abstract math problem. It is a fundamental strategic tool, one of the most powerful analytical skills you can have for a successful career, no matter what part of business you go into.
Learning this process is about making a fundamental shift in how you think as a manager. It's about moving beyond just relying on your gut feeling or what you did last year, and instead embracing a method that lets you make precise, provable, and truly optimal choices. The ability to walk into a meeting and say, according to our analysis, the best course of action is X, and here is the math to prove it, well, that gives you a level of credibility and analytical authority that will make you stand out from day one.
So I'll leave you with this final question to think about. We focused on ad spending today, but this framework, it can be applied almost everywhere. Think about it. What's the perfect production level to minimize the cost for each item you make? What's the ideal price for a new subscription service to maximize your total revenue? What's the optimal amount of inventory to keep on hand so you minimize storage costs without ever running out? Every single one of those is an optimization problem. And with the tools we've covered today, you now have the key to unlock all of their solutions.